Hey guys, today we're going to talk about solving multi-step equations. So in the last section we talked about how to solve an equation using those inverse operations when you're trying to move things from one side of the equation to the other side. So if you have more than one operation in the equation though, how do you know which one to undo first? Well, we use the same order of operations that we use for everything. Remember, we refer to that as GEMDAS. G stands for groupings, E for exponents, multiplying and dividing is your MD, and addition, subtraction are your AS. So we're still using those operations, but now we're going to use them in reverse, which, if you want to try to remember that, is sad Meg, poor Meg. So the SA is actually the first thing that we would undo. So the additions and subtractions. The DMs, or the multiplying and dividing, is what we would undo second. Any exponents would then be undone. And then lastly, any groupings. So instead of everything being our normal way of order of operations, we're going to go in the opposite direction. So let's go through a few examples. So this first one, we see 3x plus 15 equals 24. So we can see that the x is what we're trying to get to. Remember, we said to circle the x. We also talked about drawing a line right down the middle of that equals sign so that we can see the line that we have to cross over the left side and the right side. So to get the x all by itself, at the moment I can see that we have a multiplication here, 3 times x, and I also see a plus 15. So in SADMEG, I'm looking at addition, subtraction would come before multiplying and dividing. So that tells me the first thing I need to do is move that 15. So if I subtract the 15, because remember we have to, that's not a good 15. Let's get rid of that one. Let's try that again. I want to subtract 15 first because we're adding 15. So that 15 minus 15 would give me the 0, so it would cancel. Remember, I have to do it on both sides. Okay? Then I can bring down what's left over. I would have 3x on the left side, and then 24 minus 15 is 9 on the right side. Then I still have to get x by itself, so it's still not completely by itself yet. So now I would undo that multiplication of 3 times x by dividing by the 3. Now I have the 3 divided by 3 is 1x, and then 9 divided by 3 is 3. Now again, to check this, you can plug in your numbers. So 3x plus 15 equals 24. If I think the answer is 3, I plug it in for the x. And now, we don't want to confuse this, so now I'm going to use my regular GEMDAS. So when we were doing our solving of the equation, anytime I have a variable in here, that's when we use SADMEG. But over here, I have all numbers. There's no variables once I've plugged in the x equals 3 from what we think the answer is. Once I plug that in, I'm using regular GEMDAS. So that would tell me to do the multiplication first this time. And I would get, does that equal 24? That does equal 24. So it checks, which means I know the answer is 3. So you're using SADMEG when you're trying to solve an equation. When you're trying to use it to check your answer, or using all numbers and operations, you would use the GEMDAS as usual. Combining like terms to solve an equation. So remember, like terms have the exact same variable endings. So for example, 3x is a like term with 8x. They both end in x's. I could do y's with other y's if I'm adding or subtracting. They have to have the exact same variable endings for me to use addition or subtraction, okay? And you can easily combine like terms when they're on the same side of the equation. It's a little bit more challenging when they're on different sides to get them moved, but we'll be doing those as we get going a little bit further into this chapter. But when they're on the same side, we can combine the like terms. So here's an example. We have solve 8x minus 6x minus 25 equals negative 35. So the very first step that you want to do, before you start trying to think about moving things across the left side to the right side of the equation or the right side back to the left side, is to combine your like terms. So x's can be added or subtracted to other x's. So I'm going to combine everything on that side first before I start trying to move things. So what is 8x minus 6x? So remember, when I'm subtracting like terms, I would just take the 8 minus the 6. The x's would stay the same, so it's just 8x minus 6x becomes 2x. And I'm just going to bring everything else down for now, and then we'll go from there. So your first step is combine everything that can be combined to simplify the left side, and if there was stuff to do that on the right side, I would do the same thing. So now let's go through these steps that we just talked about. So we have a couple of things. We're searching for x. We're going to draw our line through the equal sign. So again, on the left side, I see multiplication right here, 2 times x, but I also see subtraction, and I need to get this x right here all by itself. So looking at SAD/MEG, the SA, so subtraction comes before the multiplying and dividing, just like we saw in the previous example. So the first thing that I'm going to do is I need to move the 25 over, and if I was subtracting, I'm now adding. And that will move it from one side to the other side. And remember, you need to do it to both sides to keep the balance. So the 25s cancel out, and I get 2x equals negative 35 plus 25, negative 10. Now I still need to get x by itself. I see 2 times x, so I'm going to divide by 2. So x, negative 10 divided by 2 is negative 5. So again, we can do the check. When you're doing the check this time, you should always go back to the original equation and then always use your regular order of operations. So I'm going to pause the video for a moment, and then I'll show you what the check looks like. So here is the check. I've plugged the x that we think is a negative 5 into the whole original equation. You don't really want to go to the 2x line. You want to start with the original one to make sure, in case you made a mistake on simplifying, that you start with where the original piece was. So remember, when I have all numbers in operations with no variables, I'm using my regular GEMDAS. So because of that, the first thing that I'm going to do is take care of these multiplications. So 8 times negative 5 is negative 40. Negative 6, think of that as a negative 6, not minus. Think of it as negative 6 times negative 5. I get a positive 30. And then minus 25. Now, again, I see addition, subtraction. Remember, when we see them both, you always take the one on the left first. So I'm going to do negative 10 from negative 40 plus 30 minus 25. Does that equal negative 35? Negative 10 minus 25. Let's remember back to 7th grade, becomes negative 10 plus the opposite of positive 25, which is negative 25. And a negative plus another negative stays negative. 10 plus 25 is negative 35. It does check. So that means x equals negative 5 is the correct answer. We have the right answer. We did a great job. We're ready to move on to the next one. Here, now we get into another one. We want to do some combining of some things first, but remember, we have our distributive property. So remember, on the distributive property, you have to multiply that outside number by both of the inside terms. Each of those things are terms, both the 1 and the negative 5x. So my very first step on this one is I want to multiply 2 times the 1. That becomes a 2. Then I come back outside and I'm going to do 2 times the negative 5x. 2 times negative 5x would become negative 10x. Don't think of it as a subtraction in the middle there. The whole term is a negative 5x. Then that means the grouping is broken up. I can bring the plus 4 down because it's not connected to that multiplication at all to get that. Now again, before we start moving things, I have regular numbers that can go together. This is a positive 2. This is a positive 4. The sign is always in front of the number. That means 2 and 4 can go together to become 6 minus 10x equals negative 8. Okay? Now, this is where I can start saying, draw that line. I'm trying to get x by itself, and think about the things that we are trying to move. So again, we have an addition, subtraction, and a multiplication in here. So one thing that I really need us to think about here, and sometimes this is a mistake, in front of the 6 is actually the sign that belongs to the 6. If I don't see anything, remember it's always positive. This minus that you see here really belongs to this 10x. Okay? So the first thing I need to do is move the 6. And I just got to make sure I move it correctly. So if I have 6 on the left-hand side, I have to move it with the opposite, which is minus 6. And this is a common mistake that some people will make, is that we see that subtraction on the left, so we add 6. But that subtraction belongs to the 10x. So then this will get rid of my 6's on the left. Remember also to bring everything down. So the negative 10x, not just positive 10x, the negative or the subtraction comes down with it. On the other side, negative 8 minus 6 is negative 14. The next step, I can now see, I see negative 10 times x. So I'm dividing by negative 10 to undo the times. That will leave me with the x, which is what we're looking for. And on the other side, we're going to see a lot of this year. This does not divide nice and evenly. I don't want the decimal version, so we don't want you to take a calculator and say 14 divided by 10. What I want you to do is leave this as a fraction, because we know fraction is really another way of division. So think through my answer here. What is a negative divided by another negative? Well, it's positive, so those two negative signs will disappear. That would give me 14 over 10. I'm very happy with an improper fraction, but can we reduce this? So is there a common factor between 14s and 10s? Yes. Both of them can be divided by 2. So if I divide them both by 2, I'm now going to get an answer of 7 over 5. I don't want to have this turn into a decimal. Don't take 7 and divide it by 5 to get the decimal version. Don't do anything else with this to make it 1 2/5. Very happy with our answer being improper, but being reduced. So I'm not going to show the check on this one, but that would be something you could also plug in and verify that it works. It does work. 7/5 is our answer, but this just is another way of seeing how to get through your distributive property. Lastly, we have a real-life application where we can see a table to the right that's talking about the number of miles that you run on a given day, Monday, Tuesday, Wednesday, Thursday, or Friday. So this one, if I read through the directions up at the top, it's saying they want to know the number of miles X that you need to run on Friday that you want to run to get to the mean of a 1.5 per day for the week. Okay? So this is an average question. We know mean means average. So let me just pause for a moment and I'll write out the equation for that and then we'll go from there. So when you're asked to find the mean or the average of stuff, you have a table or information, Remember, it's the sum or the addition of all the data divided by the number of pieces of data. This is the hashtag or number sign, okay? So what we want to do is we want to kind of fill in what we have and go from there, okay? So the question would come to, do I have the mean already? In the past, you guys used to get a bunch of information and say, find the mean. We already have the mean. It says up here, the mean of the miles run per day is 1.5. So we're going to just start filling out our equation. We want it to be 1.5 per day for the week. So the sum of the data. Well, we have some of the data, no pun intended, but we don't have all of it. So here's what we have. We know what Monday is. We know it was 2. Tuesday, we took the day off. Wednesday, we did 1.5. Thursday, we took the day off. And what we're trying to find out is what do we need to do on Friday to keep this 1.5 average for the week? And that's not an R, that's a 5 if that's confusing to you. So the number of pieces of data. So this is tricky here. We got to make sure we don't make a mistake here. So how many days are we talking about? We're actually talking about 5 days. We're not talking about 4 because we have numbers for 4. We're actually talking about 5 days. And it's important that we put that 5 because we're trying to make an average including all 5 days. But this is now the equation that we're going to solve. So the first thing we got to do is we got to kind of go through and simplify. So I get 1.5. If I add up the top, 2 plus 1.5 plus those 2 zeros, which don't matter, is going to get me 3.5 plus x over 5. Now, if I think about SADMEG, if I look at this 3.5 plus x, it's a numerator, which even though we don't see them, and we're not going to draw them, except I'm going to put them there so you can see them, a numerator itself is actually a grouping. So, because of that, I'm actually going to take care of this division bar right here. This is a fraction or division of 5. Undoing division, we do that by saying multiply. That was a terrible 5, so we're going to redo that one. We multiply to undo division. That was not much better, is it? To move the 5 from that denominator. So again, because this is saying divide by 5, I multiply by 5, okay? By doing the multiplication by 5, that gets rid of the 5 in the denominator on the right-hand side. 1.5 times 5 on the left gives me 7.5. Now I get 3.5 plus x. And I don't really care about those parentheses anymore, right? They're just the grouping was the problem because we had that division also. So now I see the x on the right-hand side, but there's nothing different. I still need to isolate that x, right? And the thing that's on the same side with it is that 3.5. So because I only have one number to move, I don't really need to worry about the operation order. I'm just going to take, and because I see a positive 3.5, I subtract the 3.5. And I get x equals 7.5 minus 3.5 is 4. So the answer to this equation that we just built, which was a complicated equation, is 4. That's not really the answer because in a real-life application or word problem, we want to give the label to this as well. So basically what we want to do is we want to answer this with, we need to run 4 miles on Friday to get that 1.5 average per day for all 5 days, which is an awful lot, obviously, when the other 2 days we did a 2 and a 1.5. So that's how you would solve some of these. We're going to see a whole lot of equations this year. It'll take some time to really get good at them, especially now that we have more steps involved. Do the best you can. Make sure you're taking good notes as to things that you are not sure about so that we can take advantage of our time together. Bring whatever questions you have to class so that we can try to help you out with that. And good luck with it, and we will see you guys soon.